SOLIDWORKS Plastics is a software simulation product used to simulate the plastics injection molding process. Now, the injection molding process, that's the plastics manufacturing process that's used to manufacture about 80% of the plastic parts that you come into contact with every day. One of the primary reasons that injection molding is used as a manufacturing process is because it's a very high volume manufacturing process. So normally when you're looking at injection molding, you're considering making hundreds of thousands, if not millions of parts per year out of one mold. Injection molding cycle times are relatively fast, anywhere from 3 to 5 seconds on the low end for overall cycle time, up to maybe 40 to 60 seconds maximum cycle times. So basically, you're producing a lot of parts, a high volume of parts in a very short period of time. So even though the cost of one individual part may not be all that much, just pennies on a dollar, because you're producing so many so quickly, the numbers get big in a hurry. Injection molds can be very expensive. They can cost anywhere from tens of thousands to hundreds of thousands to over $1 million for one mold. So you can imagine that if you by using SOLIDWORKS Plastic Simulation, if you could save just 5% on your overall cycle time, or if you could avoid just one round of costly and time-consuming mold rework, you're going to realize an incredibly quick return on investment on the investment made in SOLIDWORKS Plastic Simulation software. And then over time, because the injection molding process is such a high volume manufacturing process, if you're saving, let's say, 5% on cycle time, every time that mold cycles and produces a part or multiple parts from you, your cost savings can also grow very quickly, exponentially in a hurry. So it's not uncommon for a customer to be able to realize a savings of tens of thousands, if not hundreds of thousands of dollars on just one mold using SOLIDWORKS simulation on just that one project. When plastics material technology advances, that means that plastics the plastics that are created are higher strength and higher temperature. So as time goes on, plastics are being used more and more and more in applications that require higher strength and higher temperature resistance. As that happens, that can change the face of a whole industry, automotive industry, for example. Plastics are the single best way to lightweight a vehicle. Now, when you lightweight a vehicle, you get better gas mileage. When you get better gas mileage, that means there's less pollution, less greenhouse gases created. So those benefits go on and on and on. So over time, we see plastics being used in more and more higher strength applications, more and more higher temperature applications. As that happens, the geometry will continue to increase in complexity, hence resulting in a need for even more plastic simulation.